Hello again. Let's start up with age structure diagrams. Alright, let's get to it. So, age structure diagrams. Okay, uniform shape is zero growth. So, if it looks kind of like a rectangle to you, well not exactly, but if um, the infant and the adult bars are kind of similar in size, then I would say that's zero growth. So it's not really growing like the United States. If you can see, there's the United States right there. So narrow growth, negative growth is kind of like Japan, uh, where the birth rate bars you see they're blue right there. It's 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 a narrow base. So it's small, then it gets wide, and then it gets small again. It looks kind of like a vase. That means it's negative growth. So if you see a broad base where there's a lot of babies, you see that blue bar, then the red bar with adults, it's kind of less and less, and then it kind of looks like a pyramid. That's rapid growth, very rapid growth. Kind of places like Africa and Haiti. So the first, the number one most populated country is China, and the second most populated country is India. The most important things affecting population growth is the low status of women. If the women don't have a lot of status, um, that might affect population because they're the ones who are actually having the babies. So, um, ways to decrease birth rate is family planning, contraception, economic rewards, and penalties. So the percent of water on Earth by type. So you have 95% seawater and 2.5% fresh water. So that basically just means there's a lot of seawater on Earth. There's 2.5% fresh water, but only 0.275% water that we can actually drink safely. So that's why we have to actually clean this fresh water, um, and there's not a lot of it. So the salinization of soil is basically when these are in the very dry regions. Remember this, and water evaporates, leaving the salts behind. So you get this kind of cracked effect. Have you ever seen those movies where like they're walking in the desert and you see like all these cracks on the ground and you're like, wow, that ground must be wishing it had some water right now. Well, that's because the water evaporated from the ground, and it leaves salt behind. So here's some ways to conserve water. You can actually do this too. If you use low flow fixtures in your toilet bowls, also using gray water, composting, like actually, you search using gray water if you have the time, but it's basically um, like when you're just recycling the water over and over and over that you use again and again and again. Um, Probably not for showers, but yeah. So you can repair leaks on your own. In some industries, they actually recycle their water. Say they're washing their appliances, okay? So they wash their appliances, and all the water that they use, instead of throwing it out, they actually use it to wash the next set of appliances, the next set, and the next set, until it becomes so dirty that they cannot anymore. And then and only then do they get new water, so that they save money, time, and it's more efficient. For agriculture, the best method in watering is the drip method. It waters crops more efficiently than any of the other methods like contour planting and all those other ones. So point sources versus a point source versus a non-point source. A point source has pollution from a specific location, like a pipe, but a non-point source pollution is from over an area, such as runoff. But it doesn't just have to be runoff because you don't know exactly where the runoff is coming from. So that's why it's a non-point source. But a better example would probably be pollen. You see, that's everywhere, and it comes from the trees. You know that, but I mean, it's just everywhere. There's so much. especially in El Nino years. So um, you want to make sure that you understand that a non-point source is really dispersed. Like, you don't know where it's coming from, but a point source, you can say, hey, look, that smokestack right there from that thing, it's coming out in the air. I can see it. That's a point source, like a pipe, leaking toxic fluids. That's a point source. So BOD is the biological oxygen demand, which is the amount of dissolved oxygen needed by aerobic decomposers to break down materials. So that's basically how much oxygen that aerobic decomposers need to break down the organic materials. Now, eutrophication is algae growing rapidly caused by an excess of nitrogen and phosphorus. So if you have a lot of phosphorus runoff and nitrogen runoff, stuff like that, you're going to get a lot of algae, and this is known as eutrophication. So hypoxia is when aquatic plants die. When aquatic plants die, the biological oxygen demand rises as aerobic decomposers break down the plants, and the dissolved oxygen rate drops, and the water cannot support life. So on to the next one. Minamata disease is mental impairments that are caused by mercury. If you remember not first unit, but first semester, Minamata was when in Minamata, Japan, there was a building that was leaking toxic materials into a nearby river, and when people drank from that river, it caused mental impairments. So Minamata disease is anytime you get mercury poisoning. So you probably shouldn't eat a lot of fish because they do contain a lot of mercury.